I'm going to throw in fill cycle. Is this actually live?
We are live. Yep.
Or this is not a rehearsal, or?
No, it looks like we have about a 3-minute delay on the stream, so it still shows me looking at this monitor. So now in a few moments it'll be showing me talking to. See, I just said we're live now.
Okay. Because I'm still there. I go. There I took.
Yeah.
So that's a little while.
It's quite a delay. Yeah.
Okay. Well, we can live with that.
Yeah, it's good to know. It's just kind of something we have to keep in mind if we ever have a chat group going on.
Well, also if some shit goes down.
Yeah.
You know, we have time to kill the broadcast, right?
No, because it'll still stream it. So.
Yeah. That's interesting.
Yeah. I mean, because it's well.
Are you broadcasting over the Wi-Fi?
No, it's I'm directly connected.
Oh, sweet.
It's just because it's that lousy router we have just sitting up there in the corner.
Yeah, eventually
junky $10 one from. You really need to upgrade that thing. That's just ridiculous.
Well, right now that's not going to happen, but soon. Just not this week.
Yeah.
Now, Polymaker is shipping PC plus polycarbonate 3D print filament, and we can't necessarily talk about whether we can do that. I'm sure by the time anybody actually watches this, we'll have made the announcement that we are
about Polymaker filament.
About how we support Polymaker filament. It's going to happen.
Well, I mean, you can run just about anything through that hot end.
It's amazingly true how much that is really like we're yet to find a material that does not work through our hot end.
Here, I have it right here.
Mm-hmm.
I mean, this is it.
Uh-huh.
That's the. It's just a little mini filament tank.
Here's the beauty of that hot end. What we were using previous was the groove mount industry standard hot end. A lot of people still use that form factor, though they've changed the materials. And good riddance, because the previous material was PEAK, which is a bioplastic.
Is it the black one with the
black stuff, and then it had a beige mantle layer, and then it had a Teflon.
Hex tip, right? No, the Teflon interior, right?
Yeah.
That was
30 parts. Not fun to assemble.
Yeah.
I still remember how much not fun it is to get fiberglass on your fingers.
The Teflon would end up in your filament anyway. It would just disintegrate.
That could happen. Also, Teflon off-gas is something awful at about 247 degrees centigrade. So really, it's just and it has a very high thermal expansion coefficient. So as it would heat up, and heat creep was a huge problem on these hot ends.
I remember that.
Brass barrel, and brass is really good at conducting heat, and so is plastic in general relative to, say, stainless steel. It would conduct heat, it would get the Teflon hot, and the Teflon would then expand, and the little hole would contract. Right?
Yeah.
So we moved on from that, and we started using this hot end, which we started shipping in July of 2014. And it has made all the difference. Now we can do literally any material. We also have the nozzle size from 350 microns to 400 microns at the same time.
Yeah.
Oh my god. So worth it. So wonderful.
I don't think there was much loss between that nozzle size.
That's the thing. It's just easier. It's just tolerances are easier, you know. Our supplier was asked if it was possible that we could go down to that. Makes no difference. It's all about settings. If we can still do 50 micron layers. We can still do the same things, but it also means that we can extrude more material.
Yeah.
So it's pretty cool what we're able to do there. Let's have a look here. Right. So I'm still in the process of setting up, but I've got 5 cool things that
I'm going to move this over a little bit, so I'm not quite so sideways to the camera. Because I'm looking at myself in the mirror here, and then the mirror I say, but the camera is just like, oh my god, I'm just way over here. Actually, the stream is getting better. It's not quite.
It's catching up. It's a
little better.
Yeah,
so, moderate delay.
All right, so it's been another crazy week in the 3D printing industry.
Yeah.
Yeah.
I know it's been a crazy week in here, so I don't.
It sure has, yeah.
I haven't surfaced yet from this week.
We've had a few visitors. You know, we've had all sorts of cool stuff. We're doing cool stuff. We've got a lot of stuff on the blog. If anybody wants to check that out, go to typingmachines.com and check out the blog page. We have some cool stuff coming out later this week as well, which you'll see. We've talked a little bit about using 3D printing as an entrepreneur, and we talked about the electronics of the machine, which I'm looking at. There might be a bug on our website. I'll go ahead and fix that later on. We're in the middle of a 4-part series talking about all the ins and outs of the Series 1 and what makes the Series 1 so awesome. And we talked about the electronics.
Oh yeah, Nate did a video with me about the hot end.
Oh, cool. And there was
it's after 5 now, so it's cleanup time. But
right, yeah.
That should just be a moment.
But yeah, I mean, I recommend that you check it out. Last week we did a spotlight on the structural and the motion components of the Series 1. I'm not sure if I can be heard, but hopefully it should be a problem. Oh, we're fine. Worst case scenario, it's still episode 0, right?
I can still see the microphone reacting to you, so you should be fine.
Yes.
There's a little background hum, but I can see the peaking.
Well, it'll go away soon. I know what that's. I think I know who's using it. I think I know that it won't take very long.
Well, it's nice that the mill's done.
Exactly.
That's very exciting.
Exactly. Yeah.
Yes, we were.
New parts. Yeah.
Yes.
We have some new prototype parts.
New prototype parts. Can't talk about.
There you go. Right.
Other than that, it's a new
Super
prototype
secret,
part.
Yeah. Right.
And it's amazing. The first one was just wow.
Yeah.
Blew me away when I saw it. It was just.
And everyone will have to wait and see.
Yeah.
Just
for
ever.
Maybe it'll be a Christmas present. We can tease it.
Yeah, perhaps.
Yeah.
Who knows? Anyway, there's a few different things that are going on in the 3D printing industry. And if you want, I mean, we haven't figured out the format. Do you want to just take turns on these, or?
No. I mean, you already have it up there, and probably read more about it than I have. So if you could just like preface it, and then we can discuss.
The phrase "reading" has really been thrown around. I mean, I have read some of these. I've definitely, I've obviously vetted them to be stuff that A, we can talk about, and B, we can actually provide a useful message more than just reading it. We're here to provide insight. We're here to talk about why this matters and why you should care. And we're hoping that you'll get some form of edification in the form of industry insight as a result of hearing these news stories. So the first one I'm going to bring up comes out of Michigan Tech, as reported by 3dprintingindustry.com. They are working on a new algorithm which is meant to fight against 3D printing DRM. And so I'm going to read just a few snippets from this. As 3D printing technology becomes more widely recognized and by commercialized let me try that again. As 3D printing technology becomes more widely recognized by and commercialized towards consumers, money-hungry companies may race to patent anything under the sun in an attempt to capitalize on this ever-growing technology. There could be some major potential issues that come with the patenting of 3D printing technology, particularly given the open source contributions by the RepRap community that have also helped to make 3D printing more accessible to the general public. In a new paper from Michigan Tech's RepRap researcher in residence, that's got to be a really cool job, Joshua Pierce, the associate professor, explains that 3D printing related patents have already increased in recent years with innovation stifling implications. What do you think about that?
I'm lost.
So basically, there's actually a really interesting thing that I would recommend you do. I wouldn't recommend ever that you would stop listening to his stream, which is theoretically supposed to be awesome and engaging and captivating, but I would suggest that at some point you go onto YouTube and you search 3D printers Good Morning America 1989.
Oh yeah, that'd be funny. I'd like to see that. That'd be cool.
February, November, one of those things. Of 1989, a story was run on Good Morning America about 3D systems and how they're doing this three-dimensional printing. And Charles Hull was interviewed, and he said, well, within 5 to 10 years, 3D printing will be everywhere. We'll use it to make all sorts of things. We'll use it in manufacturing. Well, that never happened. The conversation didn't even start happening until a couple of years ago. RepRap started in 2005, which interestingly enough was exactly 20 years after Stratasys and 3D Systems started, well, really 3D Systems, they were their first, started patents. And so for 20 years, these two companies had the market on 3D printing, more or less. That's not quite accurate, but more or less those were the two big companies. So it was, Z-Core, which is now owned by one of the two. Who else? Objet, which is now, I believe, a 3D Systems company.
Yeah.
So they really had the market, and then patents expire, RepRap begins, and all of the major 3D printing company players, with the exception of Stratasys and 3D Systems, and that includes MakerBot, whether they'd like to admit that or not, are descendants of RepRap, including Taipei Machines, and we're very proud of that. PrinterBot, WellsBot, Ultimaker, all descendants, MakerGear, countless others that I can't think of at the on the spot, but any printer that you've ever seen that has that kind of tall form factor with a extruder that's hooked up to 3 equal articulating arms, that's a RepRap design, but it's a derivative. Any triangularly shaped 3D printer, the kind that kind of has the triangle that it's like a triangular prism on its side, that kind of shape, that's based on the Mendel design 3D printer, and it's come a long way, but it's still RepRap derivative. And a lot of times RepRap will come up with technology which will be adopted, which is beautiful. That's part of what makes open source amazing. And so patents have definitely had some negative implications. Now that said, Taipei Machines keeps patents. So how do we reconcile this? Well, the way we do that is Taipei Machines, we're not going to actively pursue individuals who want to work on our stuff. We've had this accessible source philosophy for a long time. If you want to play with our technology, if you think you can make it better, by all means. We have to protect ourselves intellectually, but we're trying to straddle that line between what makes between embracing open source and being part of that insofar as open source hardware, and also being, trying to run a business.
Well, isn't that kind of the combination that we settled with the hacker-friendly warranty?
Yeah.
It's like, please modify it as if you feel like it would benefit you.
Right.
We're not going to drop you in the gutter because of it.
No, we are definitely fans of the repair manifesto. If you want to send your machine back for repairs, we ask that you try to return it to its original state as best you can, but we're not going to reject it outright simply because you tried to make it into a better thing or a different thing. And therefore, a lot of our users feel freedom to modify their machine, and we have a whole section on our forum, taipeimachines.com/forum, I think. Or maybe it's forum.taipei.machines.com. We have a whole section devoted to mods. And you can see that for the whole history of our company, we've allowed that, and we want to continue allowing it because it makes better products. Some of those ideas make it into our products, and we admit it and we embrace that. Some other companies have claimed those innovations as their own. We're not going to do that. We want to find the place where, you can modify, you can follow the repair manifesto, but we still need to run a business. We can't allow for clones and other rip-off products. So the same is going on with materials. There's a lot of machines coming out now that have materials that have a little chip in them.
Oh yeah.
Right, and the chip it means you can only use their filament from that vendor. It's a very walled garden closed system. And that's not very beneficial to anybody because that means you're limited to the number of materials that you can produce, whereas Taipei Machines does the very opposite thing. We want to support as many materials as possible. We already support 40 materials. We will be supporting many more. We have hundreds in our database that we want to test and bring to market in terms of our ability to have profiles out for them. If you download our software, if you download our version of Cura, our fork of Cura for Taipei, you will find there are materials you can sort by vendor, you can sort by individual material, and you can do that. So it's interesting that Michigan Tech is looking into that, and they're trying to bring more awareness to the fact that patents, especially the way the patent system exists now, not necessarily the most conducive to innovation, shall we say.
Where are these all printing?
We're live.
What?
We're streaming live. Sorry. That's a good question. What are these all printing now?
It's one of the Thingiverse polymasks. So.
Oh, nice! I love those, like the Andros from Star Fox.
Mm-hmm.
Nice.
Yeah, there are a bunch of them. So
Nice.
It's just a long print to do some really the thorough extended testing that we do. So
Nice.
yeah.
Yeah, we do. We definitely put a good amount of mileage on these machines to make sure they are really locked in and kind of, tuned in. What's the phrase? What am I?
It's like shaking out all the bugs, basically.
Basically,
Make sure
yeah.
that there's nothing that
Right.
got missed or.
Sometimes literally shaking the machines.
There's a shake test. Yeah.
There's a shake test. Yeah. So that's the first story that I have.
Okay.
So I'm assuming that down the road we can take turns.
Yeah, we can probably have like an actual maybe we can do like a collaborative document and
Something like that.
Like
I can share this with you.
we might not even stay on the same stream. We'll probably move once it's more official.
Right.
and-
Right.
yeah.
All right. So the second story that I have comes to us from 3Ders, which have been around for quite a while, and given what their site looks like, they're putting out some really good content. Actually, they are totally reputable as a way to get 3D printing news. So that's pretty cool. They've just been around for a long time, so I just thought I'd shout them out as having been there for a long time.
Mm-hmm.
Well, it would appear that Disney research engineers are developing an automated method for creating 3D printed connectors, which is pretty damn awesome because making connectors is not easy. It's not easy no matter what form of manufacturing you're doing. It requires tight tolerances, it requires tight geometry, and so they're working on ways to basically, according to their diagram, you can check it out on their thing. This is dated October 31st, if you're looking for it on that screen.
Yeah, they have a lot of stuff here.
Yeah, they do put out a lot of news. You just literally, you give it two objects and it'll figure it out. A completely automated, almost AI-like. So they have two examples that they show. They show an iPhone and your car's dashboard. And literally it outputs the entire mechanism by which you might attach your iPhone to the stereo, which is unbelievable and pretty cool because there's a lot of times in which, don't you wish you could take this and have it and take this thing and put them both together? Like, that is definitely a thing that people could use. Certainly on my car, because I have a 99 Ford Escort, which has the most wavy, organic geometry of a dashboard you could ever imagine. Yeah. The other thing to do is a mug holder and a chair arm, and the output is a thing that kind of has these two flanges, and at the bottom of the holder has these two connectors on the bottom, like this. It might not look. I'm trying to make it. Might not be visible, but you should check out the article. And in the video description after the stream is over, we'll include links to everything. If that's possible, I'm not sure if that's possible. But
yeah, we can go back and edit it.
Beautiful. Okay, I'll send you an email. I'll just email you. And yeah, this is pretty damn cool if you look at it. I haven't actually looked at all the images. There's a video for it, which I haven't looked at, but it's called AutoConnect, Computational Design of 3D Printable Connectors. That's pretty damn cool.
Yeah, this is a really...
and some of these examples are hilarious and shockingly useful. Input: belt, can of Red Bull. Output: perfectly sized belt holder for your Red Bull. And it's a friction fit connector as well. Wow. Now that's pretty cool. That's really damn
So that's
cool.
a software that they're offering, basically.
It's an automated software. I'm not sure what form it comes in yet, but that is really, really cool. That makes designing things really easy. I actually have that article on my list.
This one?
Yeah.
Yeah, that's a good one.
So check that out.
Yeah, so we'll put that up. And all right.
So let's do that one since then. We're down to a few minutes?
Yeah, it's already 5:45.
Boy, we just... Okay, well, let's talk about the tank treads, and we can save the others for another day, or maybe not, since they're a little old.
It's kind of on the same topic line, though, of the tolerances and connectors. Although they're using looks like they're actually using bicycle chain links to make that work.
I'm not ready to say that they're bicycle chains, but they are some kind of roller chain. They might be single-speed bicycle chains, actually. Unless it says
the width, it might even be motorcycle. I'm not sure what the scale is. It's pretty large, so yeah, probably motorcycle chain or small motorized vehicle of some kind.
that's really cool.
Yeah.
So so a bunch of designers have come up with a few different ways to print tank treads, and this has industrial applications as well as maker applications.
Yeah, it really does. It's cool.
You can see this is here's a robotic platform that is on rollers, and so industrial engineers could benefit from doing this, and they could create 3D printable stuff at what would appear to be a pretty large size, because you can just print each piece of the tread on its own. So you should check that article out as well. Basically, it shows a bunch of small-scale projects, but it's actually held together with roller chain, which is not how I would have done it, but I can't think of a better way than that. So that's I wouldn't even thought to have done that. Is what I'm trying to say.
Yeah, I mean, right now, and with the way it is, it's like 3D printing is best married with some other material, like laser cut acrylic, or I was explaining to my wife recently, it's why would you 3D print a rod? You would just extrude it in steel and then cut it,
right?
Or just
and realistically, for
right now,
the entrepreneur, you buy it as an off-the-shelf part.
Right.
Part of designing a product to manufacture is using as many off-the-shelf parts as possible if you can.
Yeah, and then
it just makes your life a whole lot easier.
And then doing things that you can't possibly do with any other technique. Yeah.
Exactly.
So yeah, it's a nice coming together of all sorts of technologies.
Yep. Do we have time for another one?
Yeah.
All right. So I'm going to talk. There's a few. I'm going to go through a couple that are really quick, because there is some really cool stuff going on that I would like to share that we might not have a whole lot of time for. Two examples of 3D printing in manufacturing surfaced recently. One of which is a smartphone. It's called the X Touch. It's made by a Chinese manufacturer called Blueboo, and it has a lot of tech specs. It has the other thing. It's another smartphone. It's made with 3D printing technology.
Just the case, or
that's what I'm trying to figure out. It's using some kind of non-FDM material, but it serves as an example that 3D printing can be used in manufacturing. I'm not sure exactly the specific details. I'm still trying to figure that out, because, like I said, I didn't exactly read the thing. Doesn't have much. Actually, doesn't have a whole lot of information. Okay, so here we go. The rear shell is 3D printed. The 3D printed rear shell, says the article, with its nano-composite film craft, provides an aesthetically pleasing mirror effect. According to manufacturing, both the 3D printed component and the rest of the phone are extremely strong and flexible. The phone is housed in a CNC metal frame. Nice. But perhaps the most surprisingly tough component of the device is the Gorilla Glass 3D screen.
wow.
Well, that's not surprising, but still. Whose strength the company have demonstrated in an unusual video, placed under what appears to be a large paving stone and then struck twice with a hammer.
But the paving stone would distribute the force anyway.
That's true. But yeah, so the rear shell is 3D printed. Now, with what technology, it's not clear. I was hoping that there would be a few more details, but alas.
I would like to see them hit the phone with a hammer.
In like midair where nothing can absorb the...
Or even just put it on the ground and just crush it.
Well, I've got a car, so we can... maybe not...
Yeah, well, that would be a real life case. Oops, dropped it on the ground and I rolled over it.
So what happened to my LG Dare?
Yeah,
my LG Dare got
if it can survive a car rolling over it, then it's good.
My second one fell down the gutter of a train station during a rainstorm. I'm not even kidding. And it was beautiful, and it was horrible, and it was hilarious. And
was it still on when it was down there?
Oh, dude, it was total. It was total. It looked like it had been it looked like it was total, like as if a car had been in an accident.
Wow.
One more quick one is that Local Motors have the world's first road-ready 3D printed car. It's been unveiled. It has a $53,000 price tag. It looks very interesting. This is on 3D printing industry, and they're using, obviously they're using 3D printing in their thing. And interestingly enough, they're using the big area additive manufacturing machine, which is in Cincinnati, also known as BAM, which is funny. And they are, looks like they're getting very close to market, or they are going to be in market. So another example of where 3D printing is starting to exist in manufacturing, in additive manufacturing, not just rapid prototyping.
Are they doing the shell in 3D printing, or what is 3D printed? Okay.
I'm going to have to really look at that. This looks like, okay, so this is still a concept car, but interesting. It uses crowdsourcing. It's open source, and they want to 3D print an entire series of vehicles. That's very interesting. I feel as if we're going to be talking more about that.
You know what was funny though is that I think when you look at it, unless there's something extremely unique and customized about the car, it ends up being like 3 times the price. I think the last 3D printed car I read about was actually more than buying a new Tesla.
Yeah. Well, I mean, definitely mass customization is going to have to play a role here. If this car is going to be a viable product, something tells me it will. I mean, if it's crowdsourced, then we can just change the files. That's one of the cool things that makes 3D printing awesome, is that you can change the design in a nanosecond. You don't have to wait 6 weeks or come up with a shitload of money, excuse my language, to have all these non-recurring engineering costs, which you have to get a mold done, you have to redesign the mold.
See, that's where it always made sense to me, is like fabricating the concept car from 3D printing.
Right.
Sure, because that's probably an expensive process.
Right. So if the cost of 3D printing goes down enough, that's when it becomes viable to use 3D printing in a car, if it makes sense at all.
Yeah.
It's not 3D printing is not the final manufacturing process. Nothing will ever exist again.
Right.
Because 3D printing will always have inherent limitations. Sometimes a subtractive process is going to be the better choice. But 3D printing gives you options. It gives you the ability to do stuff that had never been done before. It gives you the continuous iteration. It gives you the rapid prototyping capabilities. And in some cases, it's going to be better. It's going to be cheaper to do small objects that are 3D printed.
Yeah.
And so it is a bit of a sea change, but obviously not for everything. And we would never suggest that it is. I've been signed out. Well, it might be a little bit difficult for me to talk about the next story because maybe not. Let me see if I can get that sentence. I'm in. I just got kicked out.
Okay.
I think it's been 2 months or whatever since I turned my computer off.
Yeah.
Okay, so my last story is a new filament that's come out.
What was that one called?
It's called a Filocycle. Launches. It's got it's a Kickstarter at the moment, and they're trying to do 100% recycled filaments. So I'm going to read the opening paragraph. The expansion of 3D printing into the consumer and prototyping markets. An abundance of plastic-based filaments may be utilized in a waste-efficient way, but still an increasing use of this technology may eventually place dangerous implications on our environment if we're unable to construct high-quality recyclable filaments. As plant-based and other recycled 3D printing materials gain traction, Filocycle has just launched a Kickstarter in an attempt to further their production of plastic-based filament sourced from top-notch recycled materials. Ranging from ABS, PET, HIP, and PLA, Filocycle is planning to utilize various types of environmental waste that us humans leave behind in order to keep our 3D printers fed in an environmentally conscious way. They're offering 6 materials based on the picture that I'm seeing here. RPLA from yogurt pots, RABS from automotive waste, RHIPS, high-impact polystyrene from automotive waste, RHIPS from disposed home white goods, because it's in the white color, a natural RPLA from commercial leftovers, and RPET from commercial leftovers. So that's entirely possible if they're actually, careful the way they're harvesting the material, because some PLA is spent. Some of these materials cannot be, like PLA, even the most recycled PLAs have a little bit of new material in there because there's only so many cycles that the material can go through from a chemical standpoint.
Right.
I don't know much more about that because I'm not a chemist, but I know that there are limitations. So if they're getting around that, then that's wonderful, and I'm hoping that we'll be able to see more of this later.
Well, that's what I'm curious about is with this material is what is the point? Life
cycle analysis. I mean, it's one of those things where what the recyclable materials that do work, the two most recyclable materials, well, in their classes, we'll say, aluminum, which is number one, head and shoulders above everything else, and PET. I bring up PET because it's the most recycled plastic.
Yeah.
PET, exactly. PET is what soda bottles are made of. And aluminum is what damn near everything metal is made of nowadays. Everything from airplanes to bicycles to this computer. Your Series 1 is also made from aluminum. I mean, it's very cheap because it's infinitely recyclable, basically.
Yeah.
PET, I'm not sure how infinitely recyclable it is. I don't know how many times you need to go through the process. But, I mean, if they can do it,
see, what would make this make sense to me is if it was instantly recyclable. Like, I was thinking like machining wax.
Yeah.
When you machine something out of the machining wax, you can just collect it all again, reheat it into a form, and then put it back on the plate and machine it again.
Yeah, the issue is that you can reheat it into a form which requires a mold. It's very difficult to extrude into filament. Now it can be done. I've seen filament extruders. I've seen industrial ones that are 30, 40 feet long.
But then I wonder, is it cheaper, or is it?
That's the reason why aluminum and PET are recycled and diligently, is because it's cheaper to recycle. The only way this makes economic sense to most people is if it's recyclable. Now, if you're doing a full-on life cycle analysis, you might choose to use more recyclable material, but there's no law that says you have to. There's no law that says you have to do a life cycle analysis. So I love the idea. I'm on board. In fact, for a personal project that I'm hoping to do sometime this or next year, I intend to use PHA, which is a biodegradable material.
Yeah.
Because in my opinion, that kind of keeps within the tenets of the RepRap project, and I like those tenets. In terms of a personal, non-commercial project, I enjoy that ideology very much, and so it all depends. It is one of those things where you have to be willing to be environmentally conscious, and hopefully this will raise awareness for that because it is an important cause.
Yeah, I think it's a great idea, and I'm looking forward to seeing where they go with it. I'd really like. It's like if I were to, what I'd like to see from backing them is that they send you samples.
Yeah. Well, let's have a look at their reward schedule. Pledge £2. You get a heartfelt welcome. You get a printed vase, 11 centimeter tall printed vase for £5.
Here's the first one. You get something,
which is about $6. So I'll go with the US dollar amounts.
Okay, so $25. You get 1 kilogram spool of the HIPS HIPS.
Yeah.
So that's decent. That's the automotive plastic.
26 you get your choice of 1 spool.
Oh, that's the early bird discount. So
right.
They still have some left. Have they been funded yet?
Not at the moment.
No. They've still got 29 days to go.
They've got 29 days to go, and they're looking to raise $23,133, which I'm assuming is a much more round number. 15,000 pounds, yeah, suspected. And they've got a good start, so hopefully they will be able to get that to happen.
I just want to know what they expect each one to cost after. I don't see anything. So you get 5 kilograms for $130, basically. So yeah, it sounds like it might be cheaper, which would be great. That people are always looking. It's cheap filament's always nice for beta testing and prototyping. I wonder again, I would like some sample packs to try out, so I could see what the tolerances are. Can I make threads with it?
Right,
Can I make mechanically useful things to try out?
Yeah.
Yeah.
I kind of have a good feeling about it. I hope it works out.
Yeah, they seem like they know. I'm glad to see people working on it, and I don't know. I'm tempted to order a spool.
Let's do it.
All right. Well, we should wrap it up for today, and we'll post those links in the description. And I think I'd like to start trying to kind of like casually spread the word a bit. Just kind of make like we should try to let local people know, like to just kind of like, hey, tell.
Keep it on our like personal Facebooks. And
Exactly.
Stuff like that,
Friends and family kind
see
of thing.
What happens,
and start getting some feedback. So.
Well, Brandon, I'm sharing the document that I have with you, which includes the links.
All right, I'll edit that tonight, and
Excellent.
yeah, that's it for today. So, in case you're watching this in the future, we're going to be doing this Wednesdays from about 5 to 6 Pacific Standard Time.
Ish. What that usually means is Brandon nags me at exactly 5 o'clock that I'm late and I should get out of my desk.
Yeah, or that I'm cleaning up and
or cleaning or whatever we're up to.
Yeah, putting these back together from the day. So, all right, that's it. Yeah. And we should work on some like ending logos and opening stuff. Maybe like some.
We'll get there. Yeah, you're right. You're absolutely right. I wonder if we can just like superimpose an image on it or something like that.
That's what I'm wondering too. Yeah. I'm going to start learning more about this X streaming so you'll probably see some more stuff coming from me on the site over the next week or so, just as I learn how to use this program and everything. Been happy with it so far, and also should be. I think I'm going to be ordering parts for my PC soon, so that'll be nice.
Oh yeah, the one that you're going to be doing something super special with?
And it has a built-in audio card, so we can actually have proper mics and audio equipment.
Oh, that's also pretty awesome.
Yeah, it's I have a cardioid 30-volt phantom power mic, so yes. All right, that's it. We're out of here.
See ya.